At the start of the 21st century, the National Science Academy of a nation such as Britain, rich in its scientific heritage and indeed still very much at the forefront in everything from stem cell research to the discovery of something like graphene, of course a body such as that must champion excellence in basic science and research, and that we continue to do. But that's not sufficient for what we, the Royal Society, see as our role increasingly in the 21st century, which is taking responsibility and ownership for the translation of scientific knowledge and the fruits of basic research into developments which will be for the benefit of society and humankind through the industrialization of these scientific ideas.
The Royal Society has an extraordinary record in innovation, and highlights, of course, are Sir Tim Berners-Lee, who was the inventor of the World Wide Web, and also Sir Alec Jeffreys, who invented DNA fingerprinting. There are several aspects to the Society's commitment to innovation. They include, for example, the Industrial Fellowship Scheme, and since 1994 there have been more than 100 industrial fellows.
We're converting the surface of aluminium into a much harder coating, a ceramic coating, by injecting energy into it through what looks like millions of little lightning bolts in every square millimetre in every second. The Royal Society Industry Fellowship is what has enabled the company to start delving in detail into the science of this process. Without that, they wouldn't have had the facilities or the people that I interact with to devote to this project and really explore more technical aspects of it and try and discover new realms of application.
To our enterprise fund, which increasingly seeks to take equity positions in startups coming out from our universities and from elsewhere in the science space in the United Kingdom.
The original idea behind the business was based around a few professors' work who had an interest in looking at novel proteins and looking at billions of them. So they invented a miniaturization technique to enable them to look at large libraries to find interesting ones. Over a few years that evolved to bring in new technology in microfluidics and engineering and automation. So the Royal Society investing into sphere fluidics was very useful to us. They were looking at excellence of science and they pushed us to accelerate that diligence process. So by doing that, that helped shape the business strategy and changed it. It really made the company much more investable.
As the new treasurer, of course, I'm responsible for the Society's finances, but I also have to play an important role in our links with industry and innovation, and this is something I'm really looking forward to.
Well, next year, and as you'll hear this evening, we plan to launch the Royal Society Year of Science and Industry. A year of science and industry gives us a strapline. It doesn't mean to say we're not doing anything now, and it doesn't mean to say we won't be doing anything after 12 months. It gives us a focus. And I would hope that during the year, we will have made better contacts with industry, we'll have had more industrialists to our meetings, we'll have identified world-class scientists in industry for the fellowship. But this is an ongoing process.
Well, the Labs to Riches event is the highlight of the Society's year as far as links to industry, innovation and entrepreneurship are concerned. One of the highlights of this occasion, of course, is that we announce the winners of the Brian Mercer Award for Innovation and the Brian Mercer Feasibility Awards.
We've placed the positioning of science within the industrial base of the nation as one of the #1 priorities for the Royal Society in the years to come.